Dear students, in this session we will learn about the Vindhyan supergroup. The Vindhyan supergroup of India is one of the largest and thickest sedimentary successions of the world. Deposited in an intracratonic basin, this supergroup is composed mostly of shallow marine deposits. The Vindhyan supergroup is believed to have recorded a considerable portion of Proterozoic time and therefore likely to contain valuable information on the evolution of atmosphere, climate and life on our planet. Before we discuss about the Vindhyan supergroup in detail, let us first get introduced to what is called as the Vindhyan range. The Vindhyan range is located in central India, Madhya Pradesh and is 970 kilometers long and 19 meters high. It has been the historic dividing line between North and South India, separating the Sanskrit-speaking Aryan invaders from the Dravidian peoples of the Deccan. The Vindhyan range is a range of older rounded mountains and hills and which geographically separates the Indian subcontinent into northern India and southern India. That is, they actually form a divide between the Indo-Gangetic plains and the Deccan region of the country. These hills are less rugged and smaller in size. The Vindhyan range originates from the state of Gujarat, continuing into the east and north. The range runs east and north nearly to the Ganges river at Mirzapur. The northern slopes of the range are drained by the tributaries of the Ganges, including the Kali Sindh, Parbati, Betwa and Ken. The Sun, a tributary of the Ganges, drains the southern slopes of the range at its eastern end. The southern slopes of the range are drained by the Narmada river, which drains further westward to the Arabian Sea in the depression between the Vindhya range and the parallel Satpura range of the south. The Vindhyan ranges somewhat restricts the path of the winds, making the area quite rough. The different slopes of the Vindhyan range are drained by the tributaries of Ganges towards the north and Narmada in the south. These ranges have huge sandstone reserve which was used to build stupas at Sanchi and other temples at Khajuraho. The Narmada Valley's northern edge is flanked by the Vindhyan range. These regions have basically the growth of dry deciduous forests. Rainfall here is actually seasonal, followed up with a long dry season which hinders the growth of natural vegetation which lose out their leaves. The Vindhyan Basin is a classic example of Proterozoic intracontinental basin that developed in the central part of the Indian Shield along with the several other basins such as Kudappa and Chhattisgarh. The strata are exposed in three major sectors: Sun Valley, Bundelkhand and Rajasthan. Substantially thick Vindhyan rocks have also been recognized under the Gangetic alluvium. The Vindhyan Basin, containing more than 5,000 meters thick sequence of sandstones, shales and limestones, occupies an area of about 1,62,000 square kilometers, of which about 80,000 square kilometers extended into the Ganga Valley in the north and northeast beneath the tertiary sediment of the Himalayan foredeep. In the southwest, the Vindhyan rocks are covered by the Deccan volcanics. The Vindhyan supergroup is the thickest Precambrian sedimentary succession of India and the duration of its deposition is one of the longest in the world. Since the earliest descriptions by Oldham, Mallet and Auden, this supergroup has received a great deal of attention and volumes of geological and geophysical data have been gathered. The importance of the Vindhyan sequences lies in the concept that because of its vastness with respect to time and space, they contain important information on the evolution of Earth's atmosphere, climate, sedimentary cover and life. Although the Vindhyans have been the focus of numerous interesting fossil discoveries from decades, the recent discoveries of non-Ediacaran race fossils and animal body fossils in the lower part of the supergroup have generated renewed interest in these rocks. These discoveries have re-established the belief that these sequences possess important information on the evolution of life on our planet. The basin is bounded by the San-Narmada geofracture in the south, the Great Boundary Fault in the west, and the Monghar-Saharaz Ridge in the east, and the Bundelkhand Massif and Indo-Gangetic Plains in the north. Bundelkhand Massif divides this basin into two parts, the Sun Valley on the southeastern side and the Chambal Valley, where exposures occur from the Agra to Chittogarh. The southern margin of the Vindhyan Basin is marked by a major east-northeast, west-southwest trending lineament termed Narmada Sun lineament, south of which occurs the Satpura origin. A northeast-southwest trending major lineament known as Great Boundary Fault separating the Aravalli-Delhi origin from the Vindhyan also marks the western margin of the Vindhyan Basin in the Rajasthan sector. The Vindhyan strata define a broad regional syncline trending east-northeast, west-southwest. The axis of this syncline is slightly curved and plunges gently towards west. The average dip of the southern limb is greater than that of the northern limb, rendering the axial plane to dip southerly. The Vindhyan Basin was formed as a result of a large crustal downwarp in the northern part of the Indian platform after the Delhi orogeny. The initial transgression of the sea from the north is inferred to have taken place in the eastern part of the basin over the Bijavars. The shallow sea appears to have established lagoonal conditions near the coastal part during the subsequent regressive phase. Initially, the San-Narmada lineament was dormant, but at the onset of the Vindhyan sedimentation, later the fault system along this downwrap became active with the formation of the southern limit of Vindhyan deposition. After the deposition of Khajrahat limestone, the San-Narmada lineament again became active, resulting in emission of volcanic material which was deposited as the Jardepahar porclanite. In the subsequent regression, the shoreline shifted towards northwest. The Fawn limestone was deposited over the shelf in a tidal flat environment. This was followed by the shallowing of the basin is as evident from the overlying glauconitic sandstone. The fresh marine transgression resulted in the deposition of marine shields followed by Rohtas limestone. The entire Vindhyan succession, maximum thickness estimated to be around 3 km and comprising mainly sandstone, shale and limestone, is assigned as the Vindhyan supergroup. The supergroup is divisible into 4 groups: Semri group, Kaimur group, Rewa group, Bhander group. Each group is again subdivided into several formations. The Semri group is the son of valley west uncomfortably on a variety of pre-Vindhyan rocks such as granites and metamorphics. In the Bundelkhand area, the group overlies the Bundelkhand granite, gneiss and Bijavar group of metamorphics, whereas in the southern Sun Valley, Mahakoshal is the basement in most places. However, in some localities, the basement is granite. The Semri succession of the Bundelkhand area has 2 detached outcrops around Chitrakoot and Bijavar respectively and is only a few tenths of kilometers thick. The different depositional systems recognized in the Vindhyan succession are alluvial fan, fan delta, Briide delta, braid plain, alluvial sand sheet, tidal flat, shores face, storm-dominated shelf, homoclinal carbonate ramp, distally steepened carbonate ramp and epieric peritidal flat. The overall paleo-current directions of the depositional systems in the Sun Valley are northerly, suggesting a source towards south. The unconformities divide the Vindhyan succession of Sun Valley into 5 sequences. Each sequence consists of several systems tracks representing different paleogeographic settings and marking paleogeographic shifts. The different strata of the Vindhyan succession show evidences of soft sediment deformation, suggesting sign sedimentary tectonic activity. The progressive and successive angular unconformities suggest that the deformation pattern shown by the Vindhyan strata is a reflection of sign sedimentary tectonic activity. It is postulated that the individual sequences of the Vindhyan succession are related to discrete episodes of tectonism that induced the subsidence necessary for accumulation of sediments and resulted into deformation of older strata. Angular unconformities results due to erosion of the uplifted crest of the anticlines on which the next sequence of strata was deposited with an angular discordance. There are sediment packages at the northern part of the Vindhyan Basin developed from a northerly source and thus representing different tracts and sequences from those of the southern part. These packages are represented intermittently in the succession and have been interpreted as representing periods of uplift of the Bundelkhand granite and subsequent erosion in the north. The paleocurrents revealed by the Vindhyan strata are typically northerly, suggesting that the evolving Satpura orogen served as the source for the Vindhyan sediments. However, the source for the clastics occurring within the Semri and the lower parts of the Kaimur and Rewa groups in the Bundelkhand sector was perhaps the Bundelkhand granite gneiss Bijawar and Gwalior group of rocks as manifested by the southerly palocrete. The Vindhyan Basin is bounded to the west by the Aravalli Mountains along the Great Boundary Fault, but is believed to continue uninterrupted beneath the Gangetic alluvial plain beyond the present north outcrop limit and below the Deccan Traps in the southwest. The Bijawar group borders the southeast margin of the basin. The rocks of the supergroup are exposed in two sectors, Rajasthan in the west and Sun Valley in the east. The general belief is that many of the Vindhyan formations of Rajasthan are laterally correlated with those in the Sun Valley. However, biostratigraphic correlation in the Vindhyans, like the Proterozoic sequences elsewhere in the world, is not robust. The Vindhyan strata are unmetamorphosed and mostly undeformed. However, there exist large-scale faults in the Sun Valley and several post-depositional faults in the Rajasthan. The upper Vindhyans in the Bundi, Sapotra, Karauli sector in the Rajasthan are significantly affected by the reactivations of the Great Boundary Fault, and hence stratigraphic correlations are tricky. The Vindhyan supergroup is composed mostly of low-dipping formations of sandstone, shale and carbonate, with a few conglomerate and volcanic beds separated by a major regional and several local conformities. The regional unconformity occurs at the base of the Kaimur group and divides the sequence into two units, Lower Vindhyans and Upper Vindhyans. It is generally believed that the Vindhyan Basin was a vast intracratonic basin formed in a response to intraplate stresses. As stated earlier, the Vindhyan Basin in central India is an intracratonic sedimentary basin with a sandstone shale limestone sequence of deposition without any metamorphic and tectonic effects. It contains the geological and evolutionary history of the Indian subcontinent hidden in these rocks, covering a very long period of Meso-Neoproterozoic eras in the geological history. Systematic studies on these rocks were initiated as long ago as 1856. Still, we know very little about them. In recent times, some advances are made with the development of new methods of date the rocks and sensitive instruments to measure their remnant magnetic directions even in limestone formations. An overview of these results of radiometric dating and paleomagnetic measurements on some of these Vindhyan supergroup rocks is discussed that bring into light some salient features with regard to the geological history, evolution of Indian subcontinent and nature of the geomagnetic field during this Meso-Neoproterozoic eras. Paleomagnetic study of the Vindhyan rocks is launched on a major scale at the National Geophysical Research Institute in order to recover the paleomagnetic signatures of the geomagnetic field during these periods to understand some of the problems associated with the evolution of the Indian subcontinent. There is a complete sequence of Vindhyan rock formations exposed in Sun Valley as well as in Rajasthan, from where the samples were studied for paleomagnetic study. The stratigraphy of the Vindhyan supergroup rocks proposed by Sony from these areas is given here. Sun Group Valley, Rajasthan, Bhander Nagod limestone, Sime Rebel Shale Tilsava limestone, Singoli limestone, Rewa Gahadra sandstone, Jiri Shale Umar sandstone, Ratanghar Shale, Dhepur sandstone, Diopura Shale, Kaimur Upar Kaimur sandstone, Bijaigarh Shale, Hinauti limestone, Deccan sandstones, Panoli Shale, Morvan sandstone, Suket Shale, Nimbahera limestone, Bhari Shale, Jiran sandstone, Simre Donar porcelainate, Kuteswar limestone Khuri, Mala conglomerate, Clary Shale, Sawa sandstone, Bhagwanpur limestone, Bhadki Shale, Karatola sandstone, Kaimurilia andesite. A generalized geological map of Vindhyan supergroup showing sample locations and typically stratigraphic section is as illustrated. Ever since the formation of the Earth, it is surrounded by its own magnetic field, which has been protecting the life and atmosphere on it over the last 4.5 GA. Rocks get magnetized at the time of their formation and serve as record to the geomagnetic field over the geological time. The study of this geomagnetic field recorded in rocks is termed as paleomagnetism, and a study of this geomagnetic field can be used to understand the evolution of different tectonic regions through geological time period. A paleomagnetic study involves recovering the magnetic signatures in the rocks through a detailed study of representative rock samples of geological formation from several sites. In situ and unmetamorphosed samples collected from the rock formations are subjected to critical laboratory demagnetizations using AF, thermal and chemical fields to recover the magnetic signature from these rock formations. These remnant magnetic signatures recovered from the Vindhyan supergroup rock formations are used in understanding the evolutionary history of subcontinent and nature of the geomagnetic field during their sedimentation period in the geological past. The Kaimur group is the lowermost group of the upper Vindhyans and dated to be at least 1200 MA on the basis of KAR and RBSR dating of kimberlites introducing the Bhagian sandstone formation around Majkhavan. Paleomagnetic study of the Vindhyan supergroup rocks has begun with a study of Gaghar quartzites around Mirzapur by Sahara Budhe and Mishra, who studied 60 samples from 20 sites. These results suggested two groups of CHRM directions with normal and reverse polarites indicating a geomagnetic field reversal and yielded a paleolatitude of 14° north to the subcontinent. The other investigation is on Bhagian sandstone of Upper Kaimur group from the Panna region by Purnachandra Rao. CHRM directions isolated from 60 samples collected at 14 sites around Panna region revealed both normal and reverse magnetic directions with upward and downward inclinations that imply two reversal of the geomagnetic field and paleolatitudes of 18 degree north and 28 degree south to the subcontinent. These paleolatitudes from the Kaimur group rocks indicate smooth passage of Indian plate from northern hemisphere to the southern hemisphere between the Malani Rhyolite and Rewa Bhander periods to form Gondwana and Pangaea along with other continents by early Paleozoic era. In a recent program dealing with paleomagnetic study of Vindhyan sediments, Dandruel sandstones from Sun Valley and its equivalent Deccan sandstones from Rajasthan were investigated. 27 oriented samples from 4 sites of Dandruel sandstones and 26 samples from 5 sites of Deccan sandstones were collected and subjected to detailed paleomagnetic tests. The NRM directions of Dandruel sandstones exhibit very good grouping with normal and reverse directions of magnetization from these sites. NRM directions of Deccan sandstones reveal only normal direction of magnetization with steep downward inclinations. It can be seen from these NRM directions that these two rock formations can be correlated, which suggests interbasinal correlation of sedimentation among the Vindhyan subbasins. The Dandruel sandstones exhibiting both normal and reverse magnetic directions of magnetization indicate a reversal of the geomagnetic field. The Rewa group occupies the middle position of the upper Vindhyans and on the basis of lithological correlations with the Jodhpur sandstones of Marwar supergroup in Rajasthan. The base of this group has been extended up to 750 MA from the radiometric dating of the Malani rhyolites underlined by the Jodhpur sandstones. Not many formations of Rewa group were investigated and only the upper Rewa sandstones from 2 areas were studied by Adhavele Elthni. These studies result in normal and reverse polarites with upward inclinations with paleolatitudes of 24 degrees south and 0.4 degree north respectively. However, recently 25 samples from 5 sites of Govindghar sandstones representing the upper Rewa sandstones around Rewa town were investigated by Purnachandra Rao. These studies reveal normal magnetic directions with upward and downward inclination identical to other studies, implying 2 reversals of the geomagnetic field during their deposition. The Jodhpur sandstones in Marwar Basin in Trans-Aravalli Vindhyans in Rajasthan, lying above the Malani rhyolites dated at 771 to 751 MA and correlated with the upper Rewa sandstones from 14 sites were investigated by Purnachandra Rao. These studies also reveal similar CHRM directions as that of the Sun Valley Rewa sandstones, confirming their correlation and assigning a lower age between 771 and 751 MA for the Rewa group. Under the Vindhyan Paleomagnetic Study program undertaken recently, Upper Rewa Govindghar sandstones from 5 sites from Sun Valley and Upper Rewa Umar sandstones and Middle Rewa Dhepur sandstones from Rajasthan were studied. CHRM directions from all the 5 sites of Govindghar sandstones reveal normal directions with both downward and upward pointing inclinations, implying to a reversal of the geomagnetic field during their deposition similar to that of upper Kaimur Vindhyan sandstones around Pana region and Baigunapalli quartzites of Kudappa supergroup for south. The Dhepur sandstones for Rajasthan reveal normal magnetization with mostly downward pointing inclination, which may also result in similar CHRM directions as that of the other upper Rewa group sandstones. The Umar sandstones being more quartzitic needed better coring bits that delayed their coring operation and studied on these rocks are in progress. Ratanghar shales were collected from Rajasthan whose NRM directions exhibit very good grouping with very steep downward inclination and normal magnetization. The CHRM direction obtained after laboratory demagnetization studies reveal normal magnetization with steep positive inclination similar to that of Malani rhyolites with a VGP close to around 800 MA. Further studies on them are in progress. In general, shales are very difficult to sample for laboratory studies. However, we are successful in collecting samples from one site for laboratory studies from Ratangarh Shale Formation that proved to be very useful. This study may result in very good correlation with Giri Shale exposed in almost all the subbasins of the Vindhyan Basin, an advantage available for Paleomagnetic Studies. The uppermost group of the Upper Vindhyans is represented by the Bhander group and widely studied among the Vindhyan rocks. The Upper Bhander sandstones were investigated by Athwele, Kotwich and McElhenney from a total of 16 sites. While Athwele reported normal magnetic directions with upward inclinations from 3 sites, Kotwich reported reverse magnetic directions with upward and downward pointing shallow inclinations from 7 sites. The studies undertaken by McElhenney show both results of Athwele and Kotwich. The studies on Bhander group rocks revealed 2 reversals of the geomagnetic field with southern paleolatitudes to the Indian subcontinent. In the recent study of Vindhyan paleomagnetism, samples were also collected from lower Bhander Nagod limestone formation from Sun Valley, Singoli limestone formations from Rajasthan and middle Bhander Tilsawa sandstone formation from Rajasthan were also collected. The Nagod limestones result in a north-northwest pointed declinations with steep downward inclinations, and the Singoli limestones exhibit well-grouped northwest pointed declinations with a very steep positive inclination. The Tilsawa sandstones from Rajasthan show well-grouped normal magnetization with steep to very steep positive inclinations. Therefore, it can be inferred that this provides very good correlation of lithological units in these Vindhyan subbasins when the CHRM directions are established. The Vindhyan range is the home of vast wildlife and forestry. Though there has been major degradation in the natural environment due to human interventions leading up to a vast array of ecological problems, these demand attention and steps have been taken up against it. Fairly enough, this place retains its charm and falls within the parameters of the fast-growing tourism industry. Though the paleomagnetic studies on the Vindhyan rocks were initiated 4 decades ago, not many formations were studied because of certain limitations such as their weak magnetic nature and non-availability of sensitive instruments for the laboratory investigations until recently. Paleomagnetic studies on the Vindhyan rocks were restricted to only red sandstones of Upper Rewa and Upper Bhander groups. A review of the available results from these rocks was provided by Purnachandra Rao. Subsequently, a major program of paleomagnetic study of the Vindhyan sediments has been initiated at NGRI, under which a large number of samples were collected representing the complete stratigraphic column of the Vindhyan supergroup from Sun Valley and Rajasthan regions. Preliminary results on some of these formations are available and very much encouraging. The following are some of the salient results that have emerged as a result of paleomagnetic study of Vindhyan supergroup rocks over the last 4 decades.